Hello, everyone. I want to show you how to implement the logistic regression process in RapidMiner, and we have two examples today. The first one is universal bank example. So you can download it from the Blackboard. We have two processes. First one is universal bank, and the next one is flight delays that I will explain both of them. You can import the process first and replace the data with the original one. And so let's look at the data set and its structure. You can see that the y variable here is binary variable, this one, personal loan. And there's a bunch of predictor variables, age, experience, income, family members. And you can see some information about the predictor variables. And we have a combination of integer and categorical variable. So let's go back to the process and move forward. So we have first data preprocessing. First, we set the select the attributes. Actually, we exclude the zip attribute using this invert selection. Then we set the personal loan as label and ID as ID. Then we map some negative values in the experience variable to 0 because negative experience value does not make sense. Then we convert a bunch of numerical values to polynomial. The only categorical variable here, which has more levels than 2, is education. So education has 3 levels, then we will convert it to polynomial. Then we will convert the numerical values to binomial. The CD account or owning the credit card or having the online account are examples of the dummy variables. So we define them as dummy variables by converting these numerical values to binomial. So that was the preprocessing. After preprocessing, you will split the data into training and test, 60% as training and 40% as test. We will send the test data to logistic regression model. So you keep all of these setting as is. And after training the data, we will send the model to apply model, and we will send the test data here as well. So we apply the model on using the logistic regression model, and now we can measure the performance. We will select the positive class as true here, and we will send the copy of the performance to leaf chart to draw the leaf chart, and we'll send a copy of model to leaf chart and one copy to result. So you will have 4 result here or 4 output. Then we can run the model and see how's the coefficients. So the most important table here is the logistic regression model. As you can see in your assignment also, I want to show the logit function and odds of the function. So to answer the question 1 in your assignment, section A, you can use this tab here. Let me go back to the RapidMiner. Yeah, here you have coefficient and the variables, and you will use this information to write your logistic regression logit model. So logit equals to, for example, education to multiply by the coefficient and so on and so forth. So you have this the output of model, And one very important thing about the coefficient is interpretation of the coefficients. So it is very important to keep in mind that we have two kinds of interpretation. The first one is where we have a regular variable like age, income, which gets any numbers. So it's continuous variable or normal variable. And we have a categorical variable. So I will start with the age coefficient to interpret. And to have a correct interpretation, you can use the textbook example or the class uh, presentation, which is uploaded here in the Blackboard. And the interpretation for this beta is when we have beta, the E uh, powered by beta is the multiplicative factor by which the odds of class 1 or the success class increases. In this case, in the case of loan, a personal loan offer, uh, when the age coefficient is negative, it shows that by 1 year increase in the age, the odds of accepting the loan actually decreases by the level of E powered by minus 0.03. Or about the income, we can say that by 1 unit increase in income, the odds of accepting the personal loan increases by E powered by this. But for the categorical variable like education and family, uh, we have the reference level. For example, you can see that we just have education 2 and 3, but we don't see the education 1 because model automatically removes one level and considers that as reference. So in order to interpret the coefficients for categorical variable, we can say that by increasing the when the coefficient is positive, the odds of accepting the personal loan for someone with education 2, the odds increases by E powered by 3.9 compared to someone with education 1. Or for someone with education 3, the odds of accepting the personal loan increases by E powered by 4.1 compared to, again, someone with education 1. So that was the interpretation and most important point about the logistic regression. Then you can see the lift chart, and you already know how to interpret the lift chart, and you can see that this is the result of prediction. We have confidence level for false and true prediction, and personal loan result for different individuals here. And this shows the confusion metrics. This is the recall, and this is the precision of the model. And in description, you have another view on the model accuracy. And some other information about your data, which is information on the initial data. So the most important tab here is a logistic regression model. And to answer your assignment, you will use the logistic regression to have the logit and the odds values. And then let me see in second question, you will use this model to predict a new customer with a new bank with this information. And then again, you can calculate the values of logit and odds from the same tab of the result. So in section A and B, you are doing the same thing, like reporting the logit and odds. But in the first part A, you are reporting for the training data, and in section B, you will report for this new bank. And in part C, you will interpret the coefficient. As I explained here, we have different interpretation for categorical and numerical variables. So keep in mind to have proper interpretation. You can also use your textbook examples to how to correctly interpret the result of coefficient. So you can refer to page 279 and interpreting the coefficients of logistic regression. And it shows you example of the interpretation of income, and then categorical variable like CD, and tells you how to interpret the categorical variable. But you can also use this simple example that I already explained to you, how to interpret the education levels coefficient and how to interpret the age and income coefficient. And they are like numerical and normal attributes. So this was the first example. Let's go over the second procedure, and the second one is predicting the flight delay. We will replace the data set here and drag and drop the flight delay data set and connect to the pre-processing. We can look at the data and see, for example, we have departure time, carrier, destination. So actually destination is origin, destination, and weather, which is binary, and dummy variable. So you have different variables to predict whether the flight has delay or it's in time. And this data is collected from all information of flights from DC area to New York. And that's why you have like a limited number of destination and origin. And this data is about the flights on 2004. So you can read more information about this data set from your textbook. Let's go over the process and see how it works. So first of all, we have data preprocessing. We select the attributes, and explained in the textbook that these attributes are not suitable for our explanatory analysis, and these are more proper attributes for the prediction. So we simply use these variables to understand the logic behind the selecting variables. You should read more and more and see more examples, and that there's no single reason to select the attribute, and you need to see different models, different data sets to understand the logic behind the model selection or feature selection. So we have these 7 attributes here. Then the next operator is converting a numerical variable or departure time to categorical variables. So actually we are considering the departure time between this range as one category, and the second category is departure time between these two variables. And similarly, we can create 14 different categories by using this logic. Then we will convert some numerical to polynomial. Let's see. So we have weekdays. We have 7 weekdays. Then we will convert all of these numbers to different categories. In the next operator, we will similarly convert the flight status to binomial variable. And in order to define that the true and false or positive and negative class meaning for the model, we defined on time as negative value and delayed as positive value. So we are looking for delayed, or we are predicting the delayed flight here. And finally, we set the flight status as our label. Then that was the pre-processing. And after that, we split the data into training and tests. And we trained the logistic regression model here. And we send 2 copies of our test data to apply model and for the lift chart. And we send the copies of model itself to apply model and lift chart. So we have 3 different outputs here, and we can run the model and see the result. Again, the most important result here is the coefficient of the variables. For example, this was the departure time, which we categorized to 14 different variables at different levels. So you can see this 13 variable because one of the categories is considered as reference. Similarly, for the carrier, we have different levels. We have different levels for daytime. So daytime, we just have 6 levels because level 4 is considered as reference. And we have weather, origin, and intercept is beta 0 actually here. So interpretation of, for example, weekday. What is the different interpretation for different weekdays that we see here? So day week 1 is Sunday here, and our reference is Thursday. So from the explanation of the data, you can understand that what was the day week 4, which is reference here. So interpretation of this coefficient, 0.35, is that when the flight is on Sunday, the odds of being delayed is increased by E powered by 0.3 compared to the reference day week, which is Thursday. So if you're comparing the Sunday and Thursday, the odds of being delay will be increased by 0.3. And similarly, you can interpret other categorical variables. And since we don't have a numerical variable, I cannot explain that for you. But for the weather, which is another categorical variable, for just 2 category, and it's dummy variable. So weather 1 is when the weather condition is not good, and the reference is when the weather condition is okay. So you can see that this is very large value, and it shows that when the weather is not good, and we have different like not suitable weather condition, the odds of flight being delayed will be increased by E powered by 13. So it's a huge number, and you can see the importance of the weather condition in predicting the delay. So that was the second example, and it was similar to our first example. And here we don't have a good recall, but the precision of the model is acceptable. And this is the prediction of the, let me see. Yeah, this is different prediction for our model, which says whether the flight will be on time or delayed based on these x's that we already defined. So again, this tab, the logistic regression model, is most important table that you will find useful information, especially this column of coefficient. It's very important to build your logit model and then interpret the coefficient for your assignment. Thank you. I will post another video for combining the model.